Alrighty, this is day 6 worksheet. You started it in class. I think all the classes are looking at the same worksheet today. I got a half an hour to give you an answer key, and there's 47 questions. So there's a lot of things I'd like to say, but I'm going to try to just do the problems. All right, so let's see. The first one you had, see if I can check myself in the corner. Equation of a line through -4, 6, and 311. I will rewrite it with the x's on the left and the y values on the right. We can see a change of 7, a change of 5, hopefully from class. And remember, changing y over changing x. Get rid of the first number by subtracting it out of the problem. Subtracting -4 makes an x plus 4 statement. And if I put it in, I have a product now that's 0, and I want 6. I got the marker. I'm done. You should be checking 311 to see if it works. So 3 plus 4 is 7. The 7's cancels. 5 plus 6 is 11. All right, you know you're right. Slope intercept. I'm just getting rid of the parentheses. There's the first multiplication. There's the second. Little shortcut. 5 times -7 minus 35 over 5. Hopefully you can see that's the same as that number. Like terms gets us the mx plus b form, which I like to call ax plus b, minus 23 over 5. And hopefully that's just review for you, that you got that, and you remember getting it in class. All right, so naming 3 points. Well, if you can take a coordinate, begin to write a sentence. I remember we had x plus 4. Then why can't we do that here and say, well, I can see a 9 getting a 2. And if you start to think about what that 7 means, you know, maybe every 7 seconds I clap 3 times. Okay, and then there's a ratio of change here. There's 16, there's 23, going up 3, there's 5, there's 8. You should take your last coordinate, plug it in, see if it works. So 23 minus 9, does that become 8? Let's see, 23 minus 9 is 14. Oh, you know, 14 is a multiple of 7. 7 goes into 14, 2 times 3 is 6, 6 plus 2 is 8. By golly, that works. I don't like dividing by negative numbers, so I'll add 2x to both sides, and if I do, I get 14x over here. It disappears over here. If I subtract 9, I got minus 17, and hopefully you got minus 17 over 14 for your x value. Remember, you can pause the video at any time and take more time with the original problem. Try to do it, but the last thing I want you doing is a problem at night and doing it wrong, because then you're getting good at doing something wrong. In class, we talked about getting rid of these fractions. Multiplying by 10 does that. 5 goes into 10 twice. 2 times 2x is 4x minus 70 equals 2 goes into 10, 5. 5 times 5 is 25x. And 10 times minus 1 is minus 10. And if you forget to multiply by 10 any of the terms, it's wrong. I'll take 4x away from 25, 21x. I'll add 10 to this side, minus 60. Looks like minus 60 over 21 is my x value. All right, we talked about 5x and 3y. 5's x product. If I make it 0, fine. Looks like y is -7. Oh no, this is the perpendicular. Oh shit, this is the perpendicular, and I thought I might need more room, so I wrote it at the bottom. All right, so I don't think I need more room. I thought I might up here. So we need to know the slope of this line. So if this went over 4 and up 1, in class we said this is going over 1 and down 4. All right, so the original slope of this picture was 1 to 4. The perpendicular, the y over the x is -4 to 1. I think if you get the original slope, there's a way to figure out the perpendicular. And we talked about the 7 as a constant. And again, if you see that number change while you watch the video, if at any time this changes, please talk to somebody on your hallway or give me a call. I'll come over and get you, and we'll get you some help. So that's constant, has nothing to do with rates of change. It's the interplay between the x's and the y's. And I don't like dividing by negatives, so I'll bring it over there. And therefore 5/3 x, 5/3 is the original slope. In other words, every 3 seconds, I'm clapping 5 times. 1, there, whatever. All right, so that's the original slope. The perpendicular is -3/5. One's going up, perpendicular is going down. I wanted to go through -9, 2. I want to write x plus 9 plus 2. And that's going to get you a check on a test, and that question is going to be on every test the rest of the semester. Every test the rest of the semester. Imagine that. Sooner you get it right, the more times you'll get it right, the quicker you'll get it right, and the more you'll understand it. So put some effort in there to learn it. I'm giving you a value for X, so let's evaluate it. Negative 25 thirds times negative 2/5 plus 3, top times top, bottom times bottom gets us 50 over 15. Oh, I should have done some cancellation here. Going too fast, I'm afraid. 50 over 15 plus 3. Let's reduce it now, divide everything by 5 there. So we got 10 over 3 plus 3. 3 is 9 over 3. So I could have made a mistake here because I'm talking while I'm working, and I don't do that so well anymore, but that's what I got. Now f of x equals this. Okay, and if we want f of x equals 11, then this thing equals 11. And now we have a snapshot. All right, so what is minus 25 over 3? It's a line. Down 25 over 3. It's a pretty steep decreasing line. And at some point, this thing hits a height of 11. All right, let's find out when. Subtract 3. 8. I'm going to multiply by 3. 24. So that's going. That's I'm going to divide by negative 25. So negative 24 over 25. Pretty darn close to 1. Negative 1. Sorry, pretty close to negative 1. Yeah, okay. And minus 25 over 3 is pretty close to negative 8. Negative 8 times negative 1 is positive 8. And 8 3 is pretty close to 11. Oh, by golly. Yeah, I didn't put a problem here. I probably erased it. And now I don't know what it is. That was stupid. Anyway, number 8, do it on your own. Number 9. No one problem is going to make or break us here. And there were a couple of problems I didn't have a chance to name that tune, to find the roots. Maybe I'll try to give you a name that tune. But let's keep going. So 2 to the x equals 116. I don't know what that is unless this becomes base 2. And 16 can be written as 2 to the 4. And what you're trying to learn is that 2 to the 4 could be communicated to you thusly. So you can think of this minus sign as putting the activity in the denominator. All right, so obviously x equals negative 4. X squared plus 8x plus 17. We just started talking about completing the square, evening off the sides of a rectangle. So that's x plus 4. That's x plus 4. That gets us the first 2 terms, and that gets us 8x here. But it also gets us 16. And we want 17, so we're really going to add 1. Now, how do you do that? Completing the square here is evening off the sides, knowing that 4 squared is 16, and we didn't want 16, so we get rid of that 16. We wanted 17. And that's your x plus 4 squared plus 1. And we're going to use that for circles, ellipses. Lots of trigonometry comes out of this process. So useful to put the time in to see how that happens. So I'll just do another one. It's so important. I'll do another one quickly. Complete the square for x squared minus 10x plus 23. I could have written this as x minus 5 squared, get rid of the 25, bring in the 23, and this thing could have been written as x minus 5 squared minus 25 plus 23 is minus 2. So let's put a number in here and see if it is the same. So let's put a number in here. What would be a nice number? I think 0 would be nice. 0, 0, 23. I think putting a 0 in here would be nice. 0 minus 5 squared minus 2. Oh yeah, that's 25 minus 2, that's 23. I think I can write this that way, and there's lots of advantages to writing it that way. We'll talk about those in class. How am I doing here? I've done that in 7 minutes, I guess. 7 minutes, 10 problems, 7 minutes. So yeah, I got another 37 problems. I better keep the pace up. Find what? I don't know what I asked you, so forget number 11. So g of x, what's g of x? G minus 1 of x means the inverse. So let's say I had this equal to 17. What would you do? You'd add 5. All right, so first thing I'm going to do in the inverse is add 5. And then I divide by 2. So over here, I'm going to divide by 2. And then I'm going to take the cube root of whatever that is. And that's what I would put in there. So that is the thing we put in our calculator. How about I pick a number like 3? 3 cubed is 27 times 2 is 54 minus 5 is 49. So 3 gets me 49. So therefore a 49 down here should get me 3. 49 plus 5 is 54. 54 divided by 2 is 27. And the cube root of 27 is 3. There's another check. Why did I ask you this problem? Because I hope the heck you didn't say 6 times that and then divide by 3. I hope you just divide 3 into 6, double each of these numbers, and we get 2.4682. Done. All right. Square root of 6 times the square root of 30 could have been written as the square root of 6 times the square root of 6 times the square root of 5. That's the square root of 30. I don't have time to explain why. But the square root of 6 times the square root of 6 is a picture. And by definition, that gets us 6. So this is 6 root 5. I have to pick up the pace or I'm not going to get this done. All right, square root of 18. Well, knowing that square root of 18 could have been written as the square root of 9 times the square root of 2 explanation given in class. That's 3 root 2. 5, 7 to 821. Well, I know that gets me a 0. Right? 5 gets me a 0. That's the minimum square area. And I want a 7. Okay, and how do I get from 7 to 21? Looks like I go up 14. And if I go over 3 units, from 5 to 8, if I go over 3 units, I have actually squared that and gotten 9 units of change. And from 7 to 21 is 14, not 9. All right. What can I do with this? I can find the desk. I can move it. So you can see the next problems as I go along. All right. Oh, that's nice. I got a perfect square. That means I can use inverse operations. I know that 20 plus 8 equals 28. So therefore, sure looks like 2x squared has to equal. Jesus God, I think this was the original question, right? 28. All right. So 2x squared equals 20. Divide by 2 gets us 10. You have to remember the plus minus. Good luck trying. All right. 4 to get an 8. Well, what's wrong with that? It's not the same base, but I can make it the same base. 2 squared x, that doesn't look like much like a 2 there. Best I can do. 8 is 2 to the 3. Well, that tells me that 2x has to equal 3 because they got the same base, and x has to equal 3 halves. Excuse the pace here. Well, let's go look at 3 halves and see if you remember what that 2 means. It means square root, and the square root of 4 cubed happens to be 8. Moving right along. Will I get this done? I don't know, but I'm stopping at 12. So x squared, what have I got here? X squared minus 2x minus 8. Well, I know what gets me x squared, and I know 2 times 4 is 8, and they're 2 apart, and I want the negative. That gets the job done. This is a little harder to do, but I know 3x times x. I write down what I know. Well, there's only one way to get 7. It's either 1 times 7 or 7 times 1. Try out which one works. 7 gets tripled, 21. I don't see that working. So therefore, I'm going to put the 1 here and the 7 here. Oh, yeah. 1 times 3 is 3. 3 and 7, that's not 12. Did I give you something that you can't work with? Maybe I wanted you to, what did I want here? Maybe I wanted you to write that in graphing form. Okay, let's hope that's the case. Maybe this can be done. I'm not going to look at it because I just tried it and I don't think it can. So I must have asked you to write it in the ax minus h squared plus k form. Probably asked you that. So a is 3. It's a given, so you take it. There's a gift. All right, that's step 1. That's one thing you got to learn. 2, this is the major one, is the x that's important is the one that lives between any 2 values that get you a constant. That's what we talked about in class. We talked about taking this and making it a rectangle as x times 3x minus 12 plus 7. And from this, I can see that I have 2 values, 0 and 4, which means my x value must be 2, the one in between it. All right, so what's the shortcut to finding that 2? Minus b over 2a. So positive 12 over 2 times 3 is 6. There's the number 2. So I get x minus 2 to minimize that area, because it's going to be the bottom of the parabola. And if I put a 2 in, I get 12 minus 24. There's that nice 2-to-1 ratio, plus 7, minus 12 plus 7, minus 5. That's probably what I asked you to do with that. rewrite that this way because you can see the roots and answer it in 5 seconds or less. That's what we'll be studying this semester. Picking up the pace. I do not expect you to be able to do that correctly yet. You got to get 3 or 4 days of practice for the majority of the group people in the class to get it right. All right, so expanding this. That's addition of 7. You can do addition last. The last thing you want to do is say 7 minus 3 is 4 because you're breaking the rules of order of operation. So this is minus 3. Remember what x minus 5 is. It's a square. It's got 4 parts to it. 2 of them are like terms. So that's x squared minus 5x minus 5x minus 10x minus 5 times minus 5, 25. That's a quadratic. So we get x squared, double that product, minus 10x, square the last term. Woo, plus 7. All right, so minus 3x squared plus 30x minus 75 plus 7, minus 68, I believe. Correct me if I'm wrong. I'm going to cover that up. I'm going to find the y-intercept, right? This is a product. What makes that product 0? Put your hand over it. Actually, putting 0 in for x. All right, so I'm putting 0 in for x, and I'm getting negative 12. That's a y-intercept. I'm putting 0 into y, because that's a product. I'll get rid of it. 3x equals 24. That's an 8. Boom. So negative 12 was the y-intercept. 8's the x-intercept. Putting a little seed, planting a little seed here. And we'll be doing that more slowly some other time. All right, so this is probably the one that I asked you to factor. Yeah, I'm sure this is the factoring one. So let's put a 3a here. Let's put an a there. Now we have choices of 1, 2, 7, and 14. That's our only choices. Sure looks like 7 times 3 is 21. So it looks like this one's going to be the 7 and that's going to be the 2, because I'm always looking at the product, the outside inside products. I'm looking at the bigger one first. It has the most effect on the middle term. So 7 times 3, 21, and I want positive 19, so I'll take 2 away and I'll make that positive. And it's really a computer-like trial and error. There is a process called factor by grouping. I don't know if it's worth teaching your first year of algebra. There are certainly more important things like learning what a logarithm is. All right, so this is length times width times area. This is a cubic. So it's really a volume statement. What gets rid of the volume of a box? Stepping on it, squeezing it. What's the last one? Height, width, length. Okay, squeezing gets rid of volume. Doing that, there's another one there, but you know what? I'm going to just keep going. So what makes the length 0? What number can I plug in here so there's no length? 0. There goes the volume. How can I get rid of that width? 3. How can I get rid of this height? 3/5. You take your time, you look at it, you figure out why, and you'll be doing yourself a favor because you're going to be doing that all semester. All right, here we go. I apologize for the pace, but it's all I can do for you right now. I got another 12 minutes for about 15 problems. All right, so what are we doing here? Putting it in graphic form. Take the gift. All right, 5 minutes ago you did this. Can you remember what we have to do to get x with a number here? I hope your brain went minus b over 2a minus b. 4 over 2 times negative 2. Sure looks like negative 1 to me, so I'll write plus 1. When I put negative 1 in, I get no area. That's the minimum of a quadrant. Well, in this case, it's going to be maximum. So let's put minus 1 in and see what we get. Minus 1 times 4 is 4. I'll cut it in half. Subtract 8 minus 6. So this is a cup shape down with a vertex of negative 1, negative 6. Now, obviously, I need to put negative 1 in here, but that's negative 2. What's negative 2 plus 4? I took the shortcut. All right. Anyway, expanding this, or what am I doing with it? Well, let's find out when it equals. Well, let's graph it. No. Let's set it to 0. Okay. And well, that's going to get some imaginary roots. What the heck? You got to learn it. So negative 7. So this is cup shape up. That's a vertex of 5, 7. We're trying to get a height of 0. And if you think that that intersects this, you're imagining things. And we'll show you why you can see that. All right, so minus 7 divided by 2. Boom, plus minus square root. Well, that's when you take the negative out and you put a little I there. And I will explain that more in class. Negative 5 becomes positive 5. Can't take time to show you all this, how it works, but just planted the seed. All right. Here's a function, couple of functions. You gotta know this for your SATs, if for nothing else. So G of 1, what's G of 1? Well, I gotta go over to the G function and plug 1 in, and I get 10. So this becomes f of 10. What's f of 10? I gotta put 10 into the f function. It's doubling and subtracting 3, so it's 17. Okay, so G of 1 means you take the number 1 and you replace x with it. Right? It's an x value. That's notation, giving you the input. That's the output. What's the inverse of f? Well, what's the inverse of doubling? We double and then we subtract. Well, I think it's add. And then instead of doubling, dividing by 2. Dividing by 2. Okay, so if you had f of x, which is 2x minus 3, and you wanted to solve for 50, well, you'd add 3. And then you divide by 2, and that's your answer. And all we're doing is taking, whatever answers you get over here and calling it x, and that's a new function. How do we find out if it works? Well, we put 10 in here, and we get 17. Over here, we put 17 in, and we get 10. We used to do things to the x's to get y, and now we're really reversing it. Okay, 17 plus 3, 20 divided by 10 by 2 is 10. Check mark. I'm good to go. All right, now I'm also looking at another, I don't know. Might have been another problem on your worksheet. I got to keep going. All right, 25 to get 1 over 25. I hope you just know it's a negative 1. All right, if you want it, that's a reciprocation exponent. So if I said, what is 7 to the negative 1? I would hope you'd say 1/7. So I hope you can just see that. What's the easy? There's 3 operations here. What's the easiest one to do? That one. And again, you're just learning, but that means cube root. So a number to the 1/3 is the same thing as asking that. And computers work good with numbers, and they probably handle that easily now, but for a while, I couldn't really get machinery to work with a radical sign. So we work with numbers nicely though. So I'm going to take the cube root of 125, which is 5. 5 to the negative 2 is 1 over 5 squared. So your answer should have been 1 over 25. This is a Pythagorean relationship. That's 100 units of area. That's 9. So that square area becomes 100 minus 9. 91 is the smaller ones that add up to the big boy, the hypotenuse, or big girl. All right, so what's this? This is the square root. So what was your answer? Square root of 91, just somewhere between 9 and 10 units. So we can go back to the original problem. You can look at a 3 and a 10. Does it make sense that I'm somewhere, some number less than 10, but bigger than 9? Sure. This has got to be the biggest. All right, 1, 2 to 7, 5. What did I ask? Oh, God. Wait a minute, I got it actually here. Do I have time? I'm wasting my time. 1, 2 to 7, 5. Yes, I got it. Oh, that's just distance formula. All right, so 1 to 7 is a change of x of 6. 2 to 5 is 3. Okay, well, there's 36 plus 9 divided by square root, right? I'm just doing Pythagoras. There's your 36. There's your 9. There's your 45. There's your square root of 45, which is the square root of 9 times the square root of 5. I suppose we could say 3 root 5 is the final answer. All right, so you got to be able to read this. So what I'm looking for is the exponent on top of a 1/4 to get x. Well, it equals 2. Well, that means I'm doing 1/4 squared, which is 1/16. Yeah, so what do you put on top of a 1/4 to get a 1/16? A 2. Now you look at that. Does that 1/4 squared get you that? Yeah. All right, so what are the 2 numbers here that we're looking for? Well, this is a product. How do you make product 0? Make some part of it 0. Well, I can't make 5 over the square root of 7 0. If you see this number change, let me know. We're going to go visit the white coats again. So it's all coming from here. So I'm hoping you can see the critical numbers 15. 15 minus 15, 0. That disappears. You get 3. Right? And, how do I get rid of the square root of 7? I make this the square root of 7 with the number 22. 22 minus 5. So I'm going to pick 22. 22 minus 15 is 7. Oh, well, that's not bad. I got rid of that. 5 plus 3 is 8. That's what you're trying to see. All right, what first rule of factoring? You'll hear this every day, the rest of the term. First rule of factoring is get rid of what's common. I can see that 5 and 10 have 5 in common, and x squared next to the 7 have x squared. Remember, x to the 7, 1, 2, 3, 4, 5, 6, 7, x squared, boom, boom. Hey, they have that in common. Both have x squared in them. So what do I do to get back to 5x to the 7th? I need the missing 5. There they are, the missing 5. What do I need to get back to minus 10x squared? I need minus 2 because I got the x squared over here. How do you write this in 5 seconds or less? Well, you start with 5. From 5 to 8 is a jump of 3. Next one is not a jump of 3. I got to move this down here. All right, the asymptotic behavior really is there, but I just got to get it out of my way. So that's a jump of 3. How do I get from 5 to 23? That's a jump of 18. This is really a 5 plus 3 sixth power. Sixth power. 1900, x minus 1900. And from 1900 to 1950, 50 years elapsed. You should throw the number 1900 in. You should throw the number 1950 in to see how this works. You're going to have to deal with it every day for the rest of the term. All right, so what's the first thing here? Well, I got a multiplication. Why don't I divide? So that means that this thing here, it's got to equal 3, right? 2 times 3 is 6, so it's got to equal 3. And I'm hoping you know that's the exponent you put on top of the 3 to get our quantity x. So the answer is 27. All right, so what are the roots here? The roots are 5 plus or minus the square root of, well, it's really 7 over 2, and that's an imaginary. Right, so there must be something going on that I'm seeing, so it can't be too hard. I guess I'm going to have to explain it to you in class. All right, x squared minus x minus 20. I'll take the easy route, and I'll write that as a product. X minus 5, x plus 4 equals 0. Well, either this parentheses or that parentheses. So if it's this parentheses, x equals 5. If we're looking at that one, it's x equals -4. And those are the two numbers that get me a solution to that equation. I know what m to the 6 over m squared is. You subtract, so that's m to the 4. And this wants me to look for exponential activity on top of n. I see it. I see it. It's a 4. That's that answer. And I'm looking for exponential activity on top of an m. I see it. I see the activity, and that activity is multiply. Because m squared times m squared 3 times gets me m on the left, m in the middle, m at the end. And if you count those up, you got 6 of them. So if this was a 2 and this was a 3, then that's m to the 6th. And we're looking for what do you put on top of m to get m to the 6th? I would say 6. Woo! Woo! 3 minutes to spare. I could have spent another little bit of time explaining something. But we got 2 more problems, and you've never seen this one before. So I got time to write it out more clearly. X minus 2 times what plus what gets me x squared minus 8x plus 11. And I got a marker. I'm going to make it happen. I'm going to make it happen. I know how to get x squared minus 8x. It's x minus 6. If I multiply that out, I got x squared minus 8x plus 12. Wait, it's great, except I want 11. I got 11 now. And that actually happens to be the same thing as x minus 2 times x minus 6 minus 1 over x minus 2. Oh, Lord, that really does equal x squared minus 8x plus 11. Oh, Lord, let's find out. This is a product. I'll put a 2 in. A 2 gets rid of that whole thing. No, it doesn't. It gets rid of a 2, gets rid of that whole thing, and I get a minus 1. That's going to be harder to see here, so forget I said that. But up here you can see it. A 2 gets us a minus 1. If this is the same calculation, then a 2's got to get us a minus 1. 4 minus 8 plus 11, which is a mistake. Where did I make a mistake? There I was. That's correct. That's correct. And I want to get 11. So that's correct. Did I write something stupid here? If I put a 2 in, that gets a -1. If I put a 2 in, oh, yes, I did. I did something stupid. So 4 minus 8, I forgot to put a 2 in. I think I put a 1 in there. So that's 15 minus 16 plus 15. Yeah, there we go. We're good. Another way of writing this, two ways, I hope you see it. One is 1/4 times 3x minus 4. But I'm really hoping you see this as 3x over 4 minus 4 over 4, which is minus 1. You got to do the division into both. A lot of students will take something like x plus 2 divided by 2, and they'll do something like that. Division does not undo addition. But division can be written as multiplication, so you got to distribute. You got to distribute. I just want to make sure somebody sees that, and you didn't, because I didn't put the camera on it. But you heard it. Maybe you saw it. Anyway, it's 12 o'clock. Somehow I got it done. And I apologize for the speed, but otherwise you wouldn't have anything in front of you. And there's no harm in doing it fast, because it plants a seed. And your brain has to have a chance to look at these things more slowly. We'll be doing that in our workshops in class, and we'll be doing it every day. And your challenge is to look at it, to connect with it. Because if you do, you're going to be a happier student, because you're going to start to see how these things work. And if you want to continue in this discipline, maybe be an architect, astrophysicist, study mathematics, there's a lot of math and a lot of the things that you're going to be, I don't know, maybe aspiring to learn how to do. So I'll upload this, and I apologize for you can blame the porcupine. All right, poor David's dog there, right? So I got pressed into action, and now I was trying to find the time to do 2 videos, and this is one of them. I still got another one, more important one to do, and they're trying to get into class right now. So bye.